Alembert Principle. Let any number of forces be applied to the ith particle of a system at any instant of time. The virtual displacement of a system refers to a change in the configuration of the system. If the system is in equilibrium, then the total force on each particle is 0. That is, Fi equals to 0, Fi into del Ri equals to 0. Where del Ri is called virtual displacement and Fi is the force in equilibrium acting on the ith particle. Since the sum of these vanishing products over all particles must likewise be 0. Therefore, summation over Fi into del Ri equals to 0. This means that if system of free particles are in equilibrium, the total work done by all forces, internal and external, in a virtual displacement is 0. Thus, for equilibrium of a system, virtual work of the applied forces vanishes. That is, summation Fi into del Ri equals to 0. This is known as the principle of virtual work or law. This principle was modified by Bernoulli and developed by D'Alembert by taking Fi equals to Pi dot, where P represents momentum and Pi dot represents force, equals to Fi minus Pi dot equals to 0. Summation within bracket Fi minus Pi dot into del Ri equals to 0. Equation 1. We may write Fi equals to Fia plus small fi. Equation 2. Where Fia applied forces acting on the ith particle, small fi forces of constraint or force of restriction of the system. From equation 1 and 2, we may write summation over Fi minus Pi dot bracket close into del Ri plus summation small fi into del Ri equals to 0. If the virtual work of the forces of constraint vanishes, the second term of equation will be 0. That is, summation within bracket Fia minus Pi dot bracket close into del Ri equals to 0. This is known as D'Alembert's principle.